Okay, go ahead.
All right. So yeah, let me introduce the other way around for installing the KLayout. So this method is for the people who are not familiar with the Docker usage and Docker I mean the installation and building. So that was also my case. So for yeah, this website will be also shared in our Slack chat and also hopefully in WebEx this chat box. Let me try it right now. It should be. Your chat, okay. I share the link of this web page. Okay, so this one, I mean, this method was verified with Windows OS, and yeah, I will go through this introductory things. Here is it was taken SSCS 2024 for explaining KLayout to the folks. And so yeah, this was verified with Windows, but I guess the flow is very similar. I believe it is also realizable in macOS. So let me also go through the things in macOS for the first time. This is also my first time. So here, as explained in this web page, I will make a new Anaconda kernel. So this one is assuming, oh, sorry, let me clarify this one first. So this method is assuming that you already have installed Jupyter Notebook in VS Code. So I'm going to use VS Code and for running Jupyter Notebook. Yeah. So if you install the Anaconda, then you're going to have this Anaconda Navigator. And let me make a new one. Let's call it open source. It's just a default Python. Create. You can see that it's setting up, or remind me later. Okay, then a new kernel is made. Let's go through it. And as like a Windows, let me make a new one. Oh, where is it? Sorry. But this one is on desktop, so I'm gonna make a new folder. So let's call open source. Let's open up VS Code. And it opens, right? Let's go back to here. Then we're gonna make a new Jupyter Notebook. Let me do like this. Okay. So here, yeah, you can open the palette using this shortcut, Control-Shift-P. In our Mac case, it's Command-Shift-P, and create new Jupyter Notebook. And it says detecting kernels. And let's select kernel, Python. And here we have open source we just made. Let's have it. And let's just test whether it works or not. So EWD. And let's save this one first. At the moment, I'm going to give a name test. And by pressing Control Enter, then you can run it. Then it is asks us to install PICO. Just install it. Yeah, it works. So it shows desktop under open source. This is the current directory path, as same as Windows case. And let's install KLayout. So KLayout install. Okay, so my method is I'm making a new file for for installing the KLayout as a separate file. So let me just save this one. KLayout install. Then we have it. And you can also run this code whether you have Git in your OS or not. Git version. Then I have Git, okay. And we can run this one. But this one is basically just downloading the things OpenFA by using git clone. Yeah, if we run this, then it is git cloning the Git repository into our here. And after it is done, then we can install KLayout. Okay, that's done. Then we can install this guy. If that was successful, you can see the result like this. This was Windows case, and okay, this is done. Then we can have we can see the result like this. And for PD case, we can also install PD case. Then the things are going on. Okay, now we have error like this, right? It just basically says that KLayout supports GDS factory version equal 7.7.0, but our PDKs are supporting 7.16 .0. But you can just ignore it at the moment because we are getting back to GDS factory version, this version 7.7.0 by running one more. Sorry, this is marked up and code. And you can install remaining packages here. Then we are running pretty print 3, and yeah, it's done. So now it's again complaining that version complete, but it's fine. We will anyway use KLayout, and this one is fine. And then now the next one is making the Python code specifically for GDS display. So again, it's just copy this one. And yeah, just run it. Then we can see that under this path, open the face off, generators, KLayout, then we can see this code. So it's basically, it has a display GDS and display component. And then one more thing is we have to fix this code. I don't know what is happening in my case, but I couldn't import pretty print in my end. So what I believe is it is not the essential, really required thing to run our KLayout for our example codes. So what I'm gonna do is comment out, making inactive for some part of the code within this port utils.py. So let's go to like this GIF. We can go to KLayout, where it is, KLayout and KLayout again, and flow, PDK, util, and sorry, here, port util, and this guy. So let's comment it out by using this shortcut. In macOS case is command and slash. And we can search this one, pretty print. So this is inactive code, and this is also inactive, and this is active code. So let's comment it out, and also remaining part, comment out. Yeah, okay, that's it. And this is all done. And let's go through the examples for generating a bear. Okay, so let me make a new, Jupyter notebook. So let's save as the layout there, and make a new folder, example here, for making the files within this folder. So let's run this code. Okay, and let's check whether we are located. Currently, we are located in open source path, but we want to jump into this XBR folder. So what I'm gonna do is let's go to this path. Then it shows, okay, our current path is this one. If we run again this one, then it shows, okay, you are located in XBR. Okay, then, and anything else is will be simple. That's what I hope. Let's try. Okay, now it works. And this one also, okay. And this one, okay, hopefully it's working. Yeah, no active PDK. Yeah, this was also same in the example, the case that was demonstrated last week. As far as I know, okay, we can generate via. Okay, then this method is also working in macOS. Yeah, then we can also go through current meter and so on, but let me just skip this part and directly move to generating analog primitives. Let's just save this one as the layout. It's called prims, but you can call it whatever you want. And X prims. Then the rest things are very similar. Let me see. Okay, so we can just copy all the things that we do. We did, sorry. And like this. Here we are located here, and we can go to Xframes. Then we are located in this Xframes path. Then let's try. Okay, then it is showing. One thing I have made, the change is if we go to the original path for explaining KLayout, then we can see that GDS display, oh, sorry, not this one. Here, display component is, within this width left part. Let me try. Yeah, so yeah, you can see that it is not showing. I don't know what is, what is the reason for not showing this one, but I just tried without giving into this width left. Then you can still show the things up. Okay, then yeah, we can generate MMOS, and we can also generate memcap, and copy and paste one by one, gathering, okay, and differential pair. Okay, differential pair. And probably we can also go to, this one is active load. I would just skip this one. Basically, active load means differential to singularity converter here. This OTA component. Anyway, so let me just go directly jump into generating OPM, also called as OTA. And this amplifier will take more or less 1 or 2 minutes, I presume. Well, let's see. Okay, now we can see op-amp generated. Yeah. So yeah, so this is it. I mean, this is the everything I prepared for today. And if we install KLayout, no, sorry, not this one. Oh, here, okay, KLayout. Then let me see for this. Yeah, I also verify this one in Windows. So for Windows guys, please download this one and install KLayout and open the KLayout and just just drag this one into KLayout program. Then you can plot this layout and also zoom in and out and probably editing the layouts more precisely. So yeah, please go ahead these examples, and if you still have any difficulties, please share in our Slack chat. Thank you.